Let me get it started. This presentation is titled the Visible Breadboard, which is a system for the dynamic, programmable, and tangible circuit prototyping with visible electricity. I'm really appreciating to the Yui Kita, who is my labmate in the University of Tokyo. We belong to the same laboratory, that is Lekimoto laboratory. My advisory is Jun Lekimoto, and I'm Yoichi Ochiai from the University of Tokyo, and I'm belonging to the JSPS, Japan Society for the Promotion Science, and currently I'm work for the Microsoft Research Redmond. So I'm really sorry I cannot attend the conference. Let me introduce myself. And my research interest is how to control the physical properties by computer. Also, some of you know the levitating spatial display called the Pixie does, which is the extension of the acoustic manipulation technology, and we can change the spatial position of the small object. And also, some of you know the BRDF bubble screen, which named the colloidal display. That is we can control the optical properties of the soap bubbles, and we can change its reflection state by the ultrasounds. So my research community is SEM SIGGRAPH, and this is the first time to attend the HCI International. So let me get started. And this is abstract, and we'd like to talk about programmable, physical, and solderless breadboard. And I told you that my research interest is how to hack the physical property, and I focused the circuit connection for this. And it can be used as an ordinary solderless breadboard, and voltage in the circuit is visualized by display, and the solid-state relays enables the circuit to be programmable. It was only appeared on the SIGGRAPH post session in the patent database, but I've never write a paper, so I'd like to publish it, so I choose HCI International. My vision is quite simple, and hack and visualize the physical properties of the DIY electronics to visualize electricity and share the circuit connection, and also we can obtain the programmability of the circuit. So let me introduce a motivation and the related work. Everybody use solderless breadboard, and they download the recipe from the web and build a circuit with it. So there are 3 points. One is learning the electronics and how to run the electronics easily. So the visualization or redo and undo will make it easier. And second is how to output the circuit directly from the computer. Generating of the physical electrical circuit is a very interesting problem, and I'd like to solve it. And the third one is how to share the physical circuit. Also, with the 3D printing technology, there are the 3D capturing device, such like a 3D camera or the Kinect or like that. But capturing the physical electrical circuit is very difficult. So that is hard problem. And we have the 3 motivation. And I'd like to explain with a drawing metaphor. And canvas is a low programmability, and the printer is middle programmability, display is high programmability, just because canvas is manipulated by the hand and need lining, and the printer is computer assisted, and the display is real time and interactive. So also every section of the programmability, it has advantage and disadvantage. Canvas is low cost, but the display is high cost. And the printer is middle, like that. And it's same things in the electrical circuit or DIY electronics. Canvas is like a breadboard. Its programmability is low, and the printing circuit is middle, and displaying circuit is high. Now the breadboard is developed by the Portugal at 1970s, and it can be obtained by the hole and the wires. And the printing circuit by the silver ink is also it is well known, but last year's Kawahara et al.'s research project, and my research project is obtained by the solid state relays in 2010. And today I try to talk about this. And this is tangible computing for the building the circuit. And it is one related work which is a React 3D, and it is a tangible circuit simulator and which visualize circuit. So there are the plate with printing electrical materials, and it is virtual circuit and using the manipulated by the hand and each materials and changing the connection of each materials, and it can visualize each visual voltage or something like that. And this is a visible breadboard, which is a visible electricity circuit board. We take the inverse method. That is, this is a physical and a real circuit. So no assistance, no other assistance by the computer. So this is a quite simple system. And the visible breadboard makes two things. One is making the connection of each parts. If we insert it manually and automatically can be generated the circuit. And second is voltage visualization. The voltage is visualized by the LED. So you can see the voltage of each point of the LED circuit. So I talk about design and implementation. And design is separated into 4 systems and 3 physical boards. One is detecting the finger, and the second is making the circuit. Third is measuring the voltage, and 4 is a LED display. So that is located in the top board, LED board, and system board. And top board we can insert the electrical components and also detecting the finger. And the third board making the circuit and measuring the voltage. Second board also displaying the voltage by the LEDs. And the first board we use capacitance change to detect the finger, and we measure the capacitance and we record it. And by using the record of the finger moves, and the circuit generated in the third board by the solid state relays. Solid state relays connect each holes and disconnect each holes. So it makes a circuit on here. At the same time, we measuring the voltage of each point, and it sent to the microcontrollers, and also we can see the displaying voltage by the layer 2. So light up with a gradation color again. And first is detecting the finger location. Second is making the circuit. Third is measuring the voltage. The fourth setting the color and visualization. So it obtained in real time. So I'll show you the implementation result. This is a visible breadboard device. It shows blue is a ground line, red is a VCC, and if we cut the connection, it's gonna be change the colors. So please look at that. They touch and making the connection, and red one is a VCC, blue one is ground. We can see the both lines. If we pick up the ground, it's gonna be all VCC, and if I pick out the VCC, it's gonna be ground. Oh, both things is disconnected. It's gonna be purple, and so the voltage visualization works very fast. So we can see the voltage at the same time with the built-in circuit, and the redo and undo can be obtained by the buttons. So we can see the circuit connection slowly by the redo and undo connection. And so this device can visualize how the voltage. This shows blue one is VCC, and the red one is ground, and the purple one is middle voltage or ground and VCC. So also we can insert the materials of each holes, and it really connected. It physically connected of each holes by making the circuit. And so also we can connect the multiple systems. By this, we can obtain such kind of the copy and paste of the circuit, or also see the voltage by the computer, or connecting that to internet, we can share the data of the circuit. It is easily to share the circuit by this device. And then I talk about the evaluation. So we make the two evaluation. One is making the connection of the circuit, and the second is checking the voltage. So this device have two functions. One is making the circuit. Second is visualizing the voltage. So we evaluate both. And this is evaluation 1, and the speed of building an electrical circuit. And the participant is 10, the male is 9, and the female is 1, and the average age is 20.8. And this is a procedure. Give the circuit diagram with 4 or 5 parts, such like a condenser, capacitor, and resistor, and coil, or something like that. And tell them how to make the connection by the solder breadboard and this system, and make the 3 different circuits with both devices. Then we measure the time to finish the circuit. And the evaluation 2 is a voltage visualization. Participant is the same, and the procedure in use the electrical circuit built on the evaluation 1, which is on our systems, and ask participant which is connection is VCC or ground or middle voltage. They answered the VCC, this is ground, or this is middle voltage. So this is the result, and the wiring is twice faster in visible breadboard, faster than the normal solderless breadboard, twice faster. Just because the wiring is very slow to connect, but under the circuit in the solderless breadboard is different shape in the circuit diagram. But this proposed system is same shape of the circuit and the breadboard, just because we can make the wire by fingers. So, and all the result too, all participants could understand the visualization, and they never mistake the VCC, middle voltage, and the ground. 3 voltage is also they can see it. And about discussion, it seems scalability in size, cost, number of holes, and result in the connection tasks. Actually, the advantage of this kind of this device is shape of the circuit. Circuit shape is the same of the diagrams, and it's very important to learners. Finally, let me conclude my research. The motivation is obtain the programmable electrical circuit, and related works. It is unique in the physical circuit about this research. And for the implementation, there are 4 functions such as the finger detection and making circuit, measuring voltage, and LED display on the 3 layers of the PCB boards. And the results and twice faster than ordinary solderless breadboards to making the circuit, and the visualization is successfully done. And the future work is to make it high resolution. So that's all. Also, you can see our project in the internet. So if you Google the visible breadboard, you can see the video or the further information about this. Please see this. So thank you very much. And this is finished for the presentation, and I'd like to appreciate Kita again. So thank you for listening.